This video is about temperature changes in the system and specific heat capacity. We talked about the specific heat capacity equation in the energy topic and showed how to rearrange it. This is more about how much temperature changes, how much energy is needed to change the temperature of a substance. So we still use the specific heat capacity equation of energy equals mass times specific heat capacity times temperature change. But we need less or more energy depending on what the substance is. For example, mass. If we've got less mass of water, we're going to need less energy. If we've got more mass of water, we're going to need more energy because mass times specific heat capacity times temperature change. The bigger this mass number, the more energy we'll need. In terms of temperature change, if we're only increasing temperature by a little bit, so in this case 10 degrees, we're not going to need as much energy. But if we're increasing my temperature by a larger amount, so in this case 90 degrees, we need more energy. And finally, the specific heat capacity, if we use different substances, so here I've got a metal cube, and on the right hand side I've got a beaker of water, equal masses or equal volumes, whatever variable we're keeping the same. The metal's got a lower specific heat capacity, which means it takes less energy to heat up. The water has got a greater specific heat capacity of 4,200, which means it requires more energy to heat up. So the greater the specific heat capacity number, the more energy we need to heat it up. For example, water, bigger number, needs more energy. Specific heat capacity of metal is lesser, we need less energy to heat up that equivalent mass of specific heat capacity. And that's why the definition of specific heat capacity is that energy to raise the temp by 1 degree C of 1 kilo of the substance.